Students, today class one more equation x equal to v naught t plus half a t square. A previous video derive an equation v equal to v naught plus at from graphical method VT graph. So now here also one more equation. What is VT graph? Derive an equation x equal to v naught t plus half a t square from VT graph, velocity time graph. So this question also 5-mark question. X is a displacement, v naught is the initial velocity, t is a time, a is the acceleration. Now prove this formula x equal to v naught t plus half a t square from velocity time graph. So already you know the VT graph. The graph obtained velocity taken along the y-axis, time along the x-axis. The graph plotting velocity taken along the y-axis, time along the x-axis. A body moving with uniform acceleration with some initial velocity. So what kind of graph here? This graph. Initial velocity v naught. AB is a straight line. This graph indicates a body moving with uniform acceleration with initial velocity. What does represent the area of the VT graph? The area of the VT graph is represented by displacement. What does the area of the VT graph? So displacement. Now this is the area. Now can you draw this area? So maybe area of the trapezium. We'll join the line here. So dotted line. So now join this point here. So this area, the structure of the area of the trapezium. Area of the trapezium equal to area of the rectangle plus area of the triangle. So now you draw one triangle here. So area of the trapezium equals what? Area of the triangle plus area of the rectangular. And also join here. So B dotted line. So what I am telling that here? A body moving with uniform acceleration with initial velocity. The area of the VT graph represents a displacement. What's the shape of the area? So this is a trapezium. So after you construct one triangle and rectangular. So here points are what? A, C. Here A, B. Now mark the point here O, here A. So now here B, this is C, this is D. So OA what? Initial velocity. B, D. Final velocity. V is a, so final velocity. V is a final velocity. V is a final velocity. So time taken along the x-axis. So O, D. To mention time t. Mention time t. So time t. Students, how to draw the diagram? First you take velocity along the y-axis, time along the x-axis. Now you get straight line AB. This graph indicates a body moving with uniform acceleration, some initial velocity. The area under the VT graph represents displacement. So what is the shape of the area? This is the shape of the area. It becomes a trapezium. So area of the trapezium equal to area of the rectangle plus area of the rectangle plus area of the triangle. So now here OA initial velocity, dB equal to what? V final velocity. The graph obtained by plotting velocity along the y-axis, time along the x-axis. Now let OA. So in a graph OA here, OA equal to what? V naught. V naught is initial velocity. OA equal to V naught initial velocity. So after what here? dB equal to what? V. dB equal to V. Final velocity. And OD equals OD equals what? T. Time in which V naught means initial velocity. V naught becomes V. So time in which V naught becomes V, initial velocity becomes final velocity, changing velocity taken for time t second. So now important points here: OA initial velocity, dB equal to V final velocity, OD equal to time t in which initial velocity becomes final velocity. What does represent? So area, this area of the VT graph. So area of the VT graph represent displacement. So displacement equal to area under the VT graph. Students, so you carefully observe your point here. So this is area under the VT graph represent displacement. So displacement equal to area under the VT graph. So area O, A, B, C, D. The area under the VT graph represent displacement. So now displacement. So symbol what we have taken for x. So area under the VT graph. Area under the VT graph means what? O, A, B, C. So this is the structure. This is the area of the trapezium. So area of the trapezium equal to area of the rectangular plus area of the triangle. Trapezium equal to area of the triangle plus area of the rectangular. Now area under the VT graph O, A, B, C, D. So area of the trapezium equal to area of the rectangle plus area of the triangle. So area of the rectangular symbol here. Area of the rectangle what? O, A, C, D. Area of the trapezium equal to area of the rectangular. O, A, C, D. This is rectangular. Plus. After here what? Area of the triangular. Area of the triangle symbol. So this is a rectangular symbol, this is a triangular symbol. So area of the rectangle what? ACB. So this is a rectangular, this is a triangular. So sum of the rectangular and area is called trapezium. Trapezium equal to area of the rectangular plus and area of the triangular. So x is the displacement. Area of the rectangular. So how to calculate area in rectangular? You know the general formula. Area equal to what? Length into breadth. Area equal to what? Length into breadth. So now this is a rectangular. OACD. So length what? OA. Students, you see that? Carefully observe here. So this is a rectangular. Rectangular area equal to length into breadth. So now length here OA and breadth into breadth. Length into breadth. So length means OA, breadth means OB. Okay, now mention here OA under what basis? Area of the rectangular. Area equal to length into breadth. So this is a rectangle OACD. So OA is a length into OD. So OD is a breadth. So length into breadth. Area equal to length into breadth. Plus area of the triangular. So this is a triangular. So area of the triangle. So already you know the mathematical formula of base height. So half 1 by 2. 1 by 2 is the general formula. This is the general equation. This is the general formula for area of the triangular of base height. So this is a triangular ACB. So now this is the base AC into, so base into height BC. Height BC. Students, now you observe this point. So here displacement equal to area under the PT graph. So area under the PT graph you observe here O, A, B, D. The structure is the area of the trapezium. So area of the trapezium equal to area of the rectangle OACD. OACD. And area of the triangle ACB. So ACB. How to calculate area in a rectangular? Area equal to length into breadth. So this is a rectangular. In this rectangular, what is the length? OA. So I mention here OA. Into breadth. Breadth what? OD. So now mention here OD. Plus area of the triangular. Area of the triangle of base height. So 1 by 2. So base what? AC. Height BC. So now x equal to OA plus into OD plus 1 by 2. And now here AC parallel to OD. AC, this line parallel to the x-axis, that is the OD. And BC, so BC written as what? DB. DB minus what? DC. 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 Now friends, now you observe here. So area of the triangular of base height. So base AC parallel to what? X-axis. X-axis what? OD. So BC. This I written as DB minus DC. So now here, students, the displacement x equal to, so OA into OD, area of the rectangular, length into breadth, area of the triangular of base into height. So this suppose this equation written as x equal to OA into OD plus 1 by 2 into what here? OD into DB minus DC here, DC. So DC parallel to where? OA. Now substituting for OA value, OD and DB. So x equal to OA what? OA equal to V0, initial velocity. So V0. And OD equals what? Time t plus 1 by 2. OD once again what? Time t into dB. So dB equal to what? In final velocity v minus OA equal to what? initial velocity v naught. Initial velocity v naught. Friends, I telling one more time. So OA initial velocity in graph OA equal to v naught. OD is a time. So v naught into t plus half. So OD t into dB. dB is a what? Final velocity v. OA what? Initial velocity. So x equal to v naught t plus half t into v minus v naught t. Now the first equation of motion. V equal to v naught plus at. The first equation of motion from VT graph, v equal to v naught plus at. So this equation written as v minus v naught equals at. V minus v naught equal to at. Now we are substituting v minus v naught equal to what? At. So x equal to, so v naught t plus 1 by 2 into t. So v minus v naught equal to what? Into at. So finally this equation x equal to v naught t plus 1 by 2 a t into t what? T square. So this is the second equation of motion, x equal to v naught t plus half a t square from VT graph.